much ever we come across, new discoveries, inventions, and findings, we still have so much things yet to find. This universe is one such place, which provides us with endless questions and entangling answers that would swirl our minds. Starting from the Big Bang to black holes, everywhere we can find a missing piece of the puzzle. But what if we can fix the whole puzzle with one solid block, a wholesome solution? That's where we get string theory, a unified theory. What is string theory? The general relativity theory proposed by Albert Einstein explains gravity, and thus explains things of larger scale. Quantum mechanics is a field of physics which explains about the particles of quantum scale. The problem arises when these two important studies are contradictory to one another. Many physicists had worked so hard to bring up a theory that could possibly explain everything, especially to bring quantum mechanics and general relativity together under one framework. Finally, physicists came up with string theory. The string theory is a theory to combine general relativity and quantum mechanics. This theory could be otherwise said as the theory of everything. In string theory, the point-like particles of particle physics are replaced by one-dimensional strings. The properties of each elementary particle depends on the vibrational pattern followed by these strings. This theory explains quantum gravity by bringing up a quantum mechanical particle called graviton, which is said as the particle to carry gravitational force. The special relativity and general relativity theory proposed by Einstein in 1905 and 1915 explained the relation between space, time and gravity. Einstein dreamt of an even larger unification, literally a unified theory. On the other hand, from the 1920s onwards, theoretical physicists started focusing on quantum mechanics, which explained about particles which are very small in scale, that they were not affected by gravity. From the 1960s, physicists started focusing on strong nuclear force, which binds protons and neutrons of the nuclei. Gabriele Veneziano, a young theorist, made a breakthrough by finding that 200-year-old formula, Euler beta function, could explain some detailed information about the strong nuclear force. After a few years, 3 more scientists added much information that Veneziano's proposal explained about the vibrational movement of the minuscule filaments of energy, which just resembles the strings from where we get the name string theory. So initially the theory proposed that the particles were tethered to the string by the strong nuclear force. Though the 1960s was a very good start for string theory based on strong nuclear force, by 1970s, physicists started finding that the theory failed to give proper calculation values. This made physicists lose their interests in string theory, but a small group of physicists who were working with string theory came up with a conclusion that the massless particles, as predicted by string theory, could be the very evidence for Einstein's long-dreamt unified theory. Later, physicists around the world started realizing that this theory could possibly unite general relativity and quantum mechanics. Physicists renewed the definition of string theory as a unified theory. This theory swirled the minds of physicists through its inconsistency and a need for 10 dimensions to complete its mathematical calculation. In 1984, 2 physicists, Schwartz and Michael Green, came up with a calculation which proved that the theory's calculation was consistent. This turned many physicists' attention towards string theory. The theory required 6 more dimensions other than the basic 3 dimensions and 4th dimension time. This part later became a hurdle as physicists were given only an option to imagine how those 6 dimensions would work. This problem provided with string theory's mathematical framework, which allows the dimensions to take any form, made it even harder for physicists to understand the theory completely. Several progressive steps were taken by physicists, which led to a better understanding about string theory. In 1995, Edward Wittenov Institute of Advanced Study rejuvenated string theory by adding a number of new features to the theory. This also included the realization of the 7 dimensions. The more exact equation also explained about the membrane-like structures of various dimensions collectively called the brands. Finally, theorists concluded this as an unification of the older versions of string theory and named it as the M-theory. In 1997, Juan Maldacena of Harvard University made another breakthrough by making a very good tie with quantum field theory, and his theory was called the antide sitter, a conformal field theory. This resulted in an even more exact equation of string theory. Supersymmetry is a quality of string, a mathematical property, which requires every known particle species to have a partner particle species and hence called as superpartner. Because of this quality, string theory is sometimes called the superstring theory. So far no superpartners have been found, but scientists believe in them because of their increased mass than their counterparts. And to detect these superpartners, machines such as the Large Hadron Collider are the possible ways to check out. If the superpartner particles are found, string theory still will not be proved correct, because more conventional point particle theories have also successfully incorporated supersymmetry into their mathematical structure. However, this theory would help us to confirm whether we are on the right track to our unification theory by giving us indirect evidence. String theory is not only a theory combining quantum mechanics and general relativity. It has shown its significance by explaining quantum gravity, the nature of black holes and gravitational interaction. The development of string theory led to the discovery of ADS, CFT correspondence, which now explains black hole information paradox, and plays a vital role in nuclear and condensed matter physics. Currently, physicists are working on string theory to understand dark matter and other complicated concepts. Though string theory is impressive with its mathematical calculations and theoretical work, it is not yet proven practically. Once we succeed in proving the theory practically, we can expect many mysteries of this universe to be revealed. Until then, let's keep searching and pondering on this universe. So we hope that you like our video. Make sure to like and subscribe to our channel for more interesting contents. Stay tuned with Black Hole of Knowledge.